Hi and welcome. My name's Michael, and in this lesson we're going to talk about binary IPs. We know that an IPv4 IP is comprised of 4 8-bit sections we call octets. And we understand the limits of an 8-bit binary number, so let's put it all into practice by working up some IPs in binary. Let's get started. So I'm here in the binary IPs section of the interactive diagram. And we have our binary helper down here at the bottom to kind of help us out a little bit. And we can just reset it with a click of the reset button. And we also have some IP addresses. We have an example here and we have an example here. So 2 examples that we'll work up. So looking at example 1, we have 192. And if we click it, we can see we're going to require a 1 in the 128 column and a 1 in the 64 column. And if we actually click it, it will create it. However, I'd highly encourage you to try to work these up manually, and then you can click it to kind of check your work. And if nothing changes, then you are correct. And if something changes like such, then you are incorrect. So 128 plus 64 equals 192. Moving to the next octet, we have 168. So we're going to need a 128 plus 1 in the 32s column plus 1 in the 8s column. So 128 plus 32 plus 8 equals 168. 128 plus 32 plus 8. And it looks good. Now, this one's really easy. It's just a 1. So there's kind of a freebie for you. And then we have 101, which is going to be 64 plus 32 plus 4. That's 100 plus 1, which is going to look like this. So moving on to example 2, we have 172.10.16.252, and I've chosen to leave in the leading zeros here just to make it a little easier to kind of see that we're working with the binary representation. Typically, we do not keep the leading zeros. So looking at 172, we're going to need a 128 plus a 32 plus an 8 plus a 4, which will look like such. The 10 is going to be easy. It's going to be a plus 8 and a plus 2 right here. 16 is going to be even easier. It's just going to be a 1 in the 16s column. And then we know that 252 is going to have a lot more 1s because 255 is the absolute limit. And so that's going to look like this. It's going to be a 128 plus 64 plus 32 plus 16 plus 8 plus 4. And of course, the maximum would include a plus 2 and a plus 1 for 255. And here's what I would encourage you to do with this section. I would encourage you to pick 5 or 10 IP addresses. Maybe they're actual IP addresses in your own organization or they're just random, and work them up on this. So let's say I want to do 10.0.1.10. I know that I'm going to need a 1 in the 8s and a 1 in the 2. That's going to be the 10. The .0 is going to be all zeros. The .1 is just going to be a 1. And then, of course, the .10 is going to be a 10 again. And so I'd really encourage you to pick 5 or 10 different IPs and get really comfortable with calculating them as binary. Now, there are binary calculators, and when you're actually subnetting, like in a production environment and something like that, you're probably not going to want to be calculating all of this by hand. And I'm going to reiterate that again when we get down here into subnet calculations. But it is important for you to understand what's going on in the background and to be able to do it by hand if you had to. So this is something you should be really comfortable with. It's kind of like arithmetic. You'll probably break out the calculator to make sure that you don't make any mistakes, but you still know how to do it with pen and paper if you have to. And so likewise with this, it should be almost second nature. You should be really comfortable with it. But then there are tools that you can use to make your life a little easier in a production environment. In the next lesson, we're going to start looking at network masking, and all of this, the last few lessons with addressing in binary and binary IPs, we're going to start to all come together with network masks. And then it's going to come together a little more with subnetting calculations, and it'll all start to kind of gel together. This lesson is now complete. Thanks for watching.